Consider a uniformly charged metallic ring of radius r and total charge q. The ring is a hollow toroid of thickness 2a, very smaller than r. This thickness can be neglected in parts A, B, C and E. The xy plane coincides with the plane of the ring, while the z-axis is perpendicular to it as shown in the figure. In parts A and B, you might need to use the formula, that is the Taylor expansion. Okay. So part A, calc electrostatic potential on the axis of the ring. तो मैं इस वीडियो में सिर्फ पार्ट A सॉल्व करूँगा, ठीक है. अगली वीडियो में सिर्फ दूसरे पार्ट B सॉल्व कर दूँगा. Okay. A1, calculate the electrostatic potential along the axis of the ring at a distance z from its center. Okay. तुमको A पॉइंट पे पोटेंशियल निकालना है इस चार्ज रिंग का. Okay. So we'll consider a small differential charge dq, ठीक है. एंड इस dq चार्ज का डिस्टेंस A पॉइंट से है smaller, so potential due to this dq charge at point A will be equals to k dq by r. ओके. तो हमको पूरे रिंग का पोटेंशियल निकालना है, तो इस एक्सप्रेशन को इंटीग्रेट कर देंगे, ठीक है. सो इट विल बी इक्वल्स टू k बाय r इंटीग्रेशन ऑफ dq. अब r क्यूब आ रहा है क्योंकि जो डिस्टेंस है हर डिफरेंशियल चार्ज का फ्रॉम पॉइंट A वो r ही होगा, ठीक है. सो इट विल बी k r बाय integration of this dq. So integration of this dq is q, so it will be equals to kq by small r. Now the small r will be equals to z square plus r square का under root. Okay, simple Pythagoras theorem. So it will be equals to kq by under root r square plus z square. This is the potential due to this ring at point A. Calculate the electrostatic potential to the lowest non-zero power of z, assuming z is very smaller than r. So when z is very smaller than r, okay, we'll just rearrange some terms in denominator. Okay, r square common ले लेंगे, and then we'll use the Taylor expansion. Okay, and then we'll get the expression of potential when z is very less than r. Now this C option says an electron mass m and charge minus e is placed at point A. Okay, assuming z is very less than r. तो जो पोटेंशियल का एक्सप्रेशन हम इस केस में जो थर्ड पार्ट में ये वाला यूज़ करेंगे जब z बहुत छोटा है r के कंपैरिजन में. What is the force acting on the electron? Looking at the expression of the force, determine the sign of q so that the resulting motion would correspond to oscillation, and assuming the moving charge does not influence the charge distribution on the ring. Okay, so we all know that F is equals to negative gradient of potential energy, so F will be equals to minus du by dz, and we can write this potential energy is equals to q into v. q है minus e and potential है ये वाला एक्सप्रेशन होगा पोटेंशियल का, so it will be e dv by dz. Okay, तो इस एक्सप्रेशन को बस z के रेस्पेक्ट में डिफरेंशिएट करेंगे हम. On differentiating this expression we'll get minus k q e z by r cube. So this is the force experienced by the electron when z is very less than r. and जो चार्ज है वो इस रिंग पे वो पॉजिटिव होगा. पॉजिटिव क्यों होगा? क्योंकि तभी जो हमारा जो इलेक्ट्रॉन है वो ऑसिलेट करेगा, क्योंकि तभी हमारा इलेक्ट्रॉन इसकी तरफ अट्रैक्ट होगा, ठीक है. क्योंकि अगर नेगेटिव होगा तो ऊपर चला जाएगा, रिपेल हो जाएगा. What is the angular frequency omega of such harmonic oscillations? So F is equals to ma, so minus kq e z by r cube is equals to ma, so A is equals to minus kq e z by mr cube. So on comparing this expression with A is equals to minus omega square z, this will be the angular frequency, that is under root kq e by mr.